Okay, so this is the first example they have in the textbook, and I'll be honest, I don't think this really works well for me, this problem particularly. They want you to do it on a graphing calculator, but that would just give you practice in using your graphing calculator. But what I'll go ahead and do, it says graph both sides of the identity. Well, we already know that cotangent theta equals this, so the graphs should come out the same. We've done the graph of a cotangent theta, and so it starts with an asymptote at 0. If I just do one period, the period for cotangent is pi, and so I'm going to have another asymptote here at pi, and then if I want to think about halfway in between, pi over 2, I'll just write that in. And then if I want to think of halfway in between and halfway in between, those are going up to -1. Oops, I didn't mark off a 1. 1 and -1. So they're going up to 1 here, down to 0, and down to -1. So it's going something like that. And that would be one period. Now, we'll go ahead and look at the other idea here, that we could make a table of values is what I'm going to do. So let's say we want to go tangent theta, and then here's theta, and then we'll do cotangent theta here. Okay, so let's think about 0 and pi over 4, pi over 2, 3 pi over 4, and then pi. So kind of making a table of values here. Okay, so think about the tangent at 0. So right here, if you're at 0, the coordinates are 1, 0. So you're doing, y over x for tangent. Tangent would be y, tangent theta would be y over x. So the tangent would be 0. But what happens when you do the reciprocal? Well, you get 1 over 0, which is undefined. And so you're going to get an asymptote there. And we have that. So that's what we were expecting. At pi over 4 then, right here, or you can think 45 degrees if you want, the tangent there, it's the point, the square root of 2 over 2, square root of 2 over 2, and then that's just going to be 1 when you do y over x, right? Well, the reciprocal of 1 is also 1. And then you're up here at pi over 2 at the point 0, 1. Well, it's undefined for a tangent, but if I do the reciprocal, I'll get 0, right? Okay, so x over y would be the reciprocal. And then over here, you're going to have 3 pi over 4. Well, the tangent's going to be negative, so you're going to get -1. The reciprocal is going to be -1. And then you're down here at pi, the point -1, 0. Well, it's 0 for tangent, but for cotangent, it's going to be undefined, and that's going to give you another asymptote. Okay? Now, if you transfer all this information here to the graph, okay, here's pi over 2, pi over 4, and 3 pi over 4. And then we said, okay, well, there's, an asymptote here at 0. There's an asymptote here at pi. This is one period. And then we had the points right here, 1, 1. I forgot to mark the ones. 1, 1. I'm sorry, pi over 4, 1, not 1, 1. Pi over 4, 1. That's what our theta is. And then pi over 2 is 0. And then 3 pi over 4 was at -1. And so, yeah, we get the same graph. That's what we were planning on. So they're supposed to look the same. Okay, so I don't know. It's good to review this, and hopefully you're a little more familiar with the cotangent curve and the tangent curve and how that all works. Okay. Oh, shoot. I've lost it.